In the cold, distant reaches of our solar system, beyond Jupiter and Saturn, lies Uranus, an ice giant with turquoise clouds and faint rings. Uranus holds many mysteries, including its moons. These icy satellites orbit the planet. Miranda, discovered in 1948, is the smallest and most intriguing. Its chaotic surface hints at a complex past. Miranda's surface is a canvas of deep canyons, towering cliffs, and vast plains. These features are unlike anything found elsewhere in the solar system, making Miranda a true enigma. The moon's surface is a mystery waiting to be solved, a puzzle that continues to fascinate scientists. What forces could have created such a strange and wondrous world? What secrets does Miranda hold about the history of our solar system? In this exploration of Miranda, we will delve into the heart of this mysterious moon. We will uncover the secrets of its discovery, its composition, and the forces that have shaped its unique surface. Join us as we journey to the outer reaches of our solar system and unravel the mysteries of Miranda, the enigmatic moon of Uranus. The year was 1948. The world was still recovering from the ravages of war, and the space race was yet to begin. It was a time when the vast expanse of our solar system remained largely unexplored. Astronomers, armed with powerful telescopes, scoured the night sky, hoping to catch a glimpse of the unknown. It was during this time on a cold February night that Gerard Kuiper, a Dutch-American astronomer, made a remarkable discovery. Kuiper, working from the McDonald Observatory in Texas, was observing Uranus. He was particularly interested in the faint points of light that surrounded the distant planet, its moons. Uranus was already known to have 5 large moons, discovered over a century earlier. Kuiper, however, suspected there might be more, smaller moons orbiting the ice giant. His suspicions were soon confirmed. On February 16, 1948, Kuiper noticed a faint object moving near Uranus. It was extremely faint, barely discernible against the backdrop of stars, but Kuiper, with his keen eye and years of experience, recognized it for what it was, a new moon of Uranus. This discovery was met with excitement in the astronomical community. It was a reminder that our solar system still held many secrets, waiting to be uncovered. The newly discovered moon was initially designated as Uranus 5, following the convention of naming moons based on their order of discovery. However, it wasn't long before it received a proper name. Kuiper, in keeping with the tradition of naming Uranian moons after characters from the works of William Shakespeare and Alexander Pope, chose a name that reflected the moon's enigmatic nature. Kuiper named the moon Miranda after a character from Shakespeare's play The Tempest. Miranda, the daughter of the magician Prospero, is raised in isolation on a remote island. She is innocent and naive, her world limited to the confines of her island home. The choice of name seemed fitting. Miranda the moon was also isolated, a small world in the distant reaches of our solar system. Its surface, yet to be seen in detail, was a mystery, much like Miranda's own unexplored world. The name Miranda stuck, and the moon has been known by that name ever since. Little did Kuiper know at the time that his discovery would go on to become one of the most intriguing objects in our solar system. Miranda, once a faint dot in Kuiper's telescope, would soon reveal itself to be a world of astonishing complexity and beauty, a testament to the powerful forces that shape our universe. Miranda, like many celestial bodies in the outer solar system, is not a place of warmth and light. It is a world of frigid temperatures and perpetual twilight, its surface a canvas of ice and rock. This composition places Miranda firmly in the category of icy worlds, a class of celestial objects found throughout the outer solar system. These worlds, often moons of gas giants, are characterized by their abundance of volatile substances, such as water ice, methane, and ammonia. Unlike the rocky planets of the inner solar system, Like Earth and Mars, Miranda's surface is not dominated by silicates and metals. Instead, it is the presence of ice that defines its character. This ice, however, is not merely frozen water. It is thought to be a mixture of various ices, including water ice, methane ice, and perhaps even ammonia ice. These ices, mixed with rocky materials, create a surface that is both familiar and alien. To understand Miranda, we need to delve into its vital statistics. Miranda is a relatively small moon, with a diameter of approximately 470 kilometers. To put that into perspective, it is less than 1/15 the diameter of Earth. Its small size means that it has a relatively weak gravitational pull, about 0.08% that of Earth's gravity. This weak gravity has profound implications for Miranda's ability to retain an atmosphere. With such a weak gravitational pull, any atmosphere Miranda might have once possessed would have long since escaped into the cold vacuum of space. This lack of an atmosphere contributes to the extreme temperature variations on its surface. Without an atmosphere to regulate temperature, Miranda's surface experiences swings of hundreds of degrees. During its long, slow orbit around Uranus, which takes about 34 hours, one side of Miranda faces the sun, while the other remains shrouded in darkness. The interplay between Miranda and Uranus is a delicate dance of gravity. Miranda is tidally locked to Uranus, meaning that the same side of the moon always faces the planet. This tidal locking, a common phenomenon among moons in our solar system, is caused by the gravitational tug-of-war between the two bodies. Over time, this gravitational interaction slows down the moon's rotation until it becomes synchronized with its orbital period. This tidal locking, while seemingly mundane, has profound implications for Miranda's geology. The constant gravitational pull of Uranus on Miranda's interior generates heat through a process known as tidal heating. This internal heat, generated deep within the moon, has played a significant role in shaping Miranda's unique and chaotic surface. Miranda's surface is a testament to its violent and tumultuous past. The moon bears the scars of ancient impacts, tectonic activity, and perhaps even cryovolcanism. These processes, driven by tidal heating and the relentless bombardment of space debris, have left their mark on this small, icy world. Understanding these processes is key to unraveling the mysteries of Miranda's evolution. The most striking features on Miranda's surface are its vast, fault-bounded canyons, some of which are up to 12 times deeper than the Grand Canyon on Earth. These canyons, known as coronae, are unlike anything found elsewhere in the solar system. Their formation remains a subject of debate among scientists, but they are thought to be the result of tectonic forces acting on Miranda's icy crust. Miranda's surface is a breathtaking tapestry of contrasting terrains, each with its own story to tell. Scientists have identified 3 distinct types of terrain on Miranda-cratered terrain, coronae and regiones. These terrains are thought to represent different geological ages and processes, providing a glimpse into Miranda's long and complex history. The cratered terrain, as its name suggests, is heavily pockmarked by impact craters, evidence of billions of years of bombardment by asteroids and comets. The coronae, on the other hand, are vast, elliptical regions characterized by concentric rings of ridges and troughs. These unique features are thought to have formed through a process known as tectonic resurfacing, where warm, buoyant ice from Miranda's interior rose to the surface, pushing and deforming the existing crust. The regiones are relatively smooth plains that appear to be younger than the cratered terrain, suggesting that they were resurfaced at some point in Miranda's past. Section 2. Verona Rupes, a cliff of epic proportions. Among Miranda's features, one stands out, Verona Rupes, the tallest known cliff in the solar system. with a vertical drop of 5 to 10 kilometers. The sheer scale is difficult to comprehend. Section 3. The role of tidal heating. To understand the forces that have shaped Miranda's unique surface, we must delve into the Moon's interior. While we cannot directly observe Miranda's core, scientists believe that it is composed of a mixture of rock and ice. This icy core, subjected to the relentless gravitational pull of Uranus, undergoes a process known as tidal heating. As Miranda orbits Uranus, its elliptical path causes the gravitational force exerted by the planet to vary slightly. This variation in gravitational force creates tides within Miranda's icy core, similar to the tides that the Moon causes on Earth's oceans. However, unlike Earth's tides, which involve the movement of liquid water, the tides within Miranda's core cause the ice to flex and deform. This constant flexing generates heat through friction, much like rubbing your hands together generates warmth. Section 4. A frozen record of time. Miranda's surface is a frozen record of time, preserving billions of years of geological activity. Its patchwork terrains, towering cliffs, and vast canyons tell a story of a world shaped by internal and external forces. Even in the coldest reaches of our solar system, nature creates beauty and complexity. Miranda serves as a beacon of the unknown, reminding us there's much to learn about our solar system. For decades after its discovery, Miranda remained a distant enigma. Telescopes on Earth could only reveal the Moon as a faint point of light, its surface features obscured by distance and the limitations of Earth-based observation. Scientists could only speculate about the nature of Miranda's surface, its composition, and the forces that had shaped it. It wasn't until the dawn of the space age that humanity finally had the opportunity to peer beneath Miranda's veil of mystery. The opportunity came in the form of Voyager 2, a robotic spacecraft launched by NASA in 1977 on a grand tour of the outer solar system. Voyager 2's mission was to explore the gas giants Jupiter, Saturn, Uranus, and Neptune, and their respective systems of moons and rings. The spacecraft carried a suite of scientific instruments, including cameras, spectrometers, and magnetometers, designed to study the planets and their environments in unprecedented detail. In January 1986, after a journey of nearly a decade, Voyager 2 made its closest approach to Uranus, becoming the first and to date only spacecraft to visit this distant ice giant. As Voyager 2 sped through the Uranian System, it captured stunning images of Uranus's pale blue atmosphere, its faint rings, and its retinue of icy moons. Among these moons, Miranda stood out as a world of astonishing complexity and beauty. Voyager 2's flyby of Miranda was a fleeting encounter, lasting only a few hours. But in that brief time, the spacecraft's cameras and instruments revolutionized our understanding of this enigmatic moon. Voyager 2's images revealed a surface unlike anything ever seen before, a chaotic patchwork of terrains, towering cliffs, and vast canyons. The images were breathtaking in their detail, revealing features as small as a few kilometers across. Voyager 2's flyby of Miranda was a triumph of human ingenuity and exploration, providing an unprecedented glimpse into the hidden wonders of the outer solar system. The data and images returned by the spacecraft revolutionized our understanding of this enigmatic moon, revealing a world of unexpected complexity and beauty. However, Voyager 2's flyby was just a fleeting glance, leaving many questions unanswered and fueling a desire for further exploration. One of the most enduring mysteries surrounding Miranda is the origin of its unique and chaotic surface. While scientists have proposed several theories to explain the formation of Miranda's coronae, cliffs, and canyons, a definitive answer remains elusive. Was Miranda's surface shaped by a catastrophic impact early in its history, Or is it the result of more gradual geological processes, such as tidal heating and tectonic activity? To answer these questions and unravel the remaining mysteries of Miranda, a new generation of spacecraft, equipped with more advanced instruments and capable of longer duration missions, will be needed. These future missions could include orbiters designed to study Miranda's surface and interior in detail, as well as landers that could analyze the composition of its icy crust and search for signs of past or present geological activity. The exploration of Miranda is not merely about understanding a single distant moon. It is about unraveling the story of our solar system, about piecing together the history of how planets and moons form and evolve. Miranda, with its unique and enigmatic surface, holds clues to the processes that have shaped icy worlds throughout the solar system, from the moons of Jupiter and Saturn to the distant dwarf planets beyond Pluto. Miranda's tortured surface, a chaotic blend of ancient and recent geologic activity, holds profound implications for our understanding of icy worlds. Scattered throughout our solar system, particularly in the icy realms beyond the asteroid belt, these worlds represent a significant portion of the solar system's real estate. By studying Miranda, we gain insights into the processes that have shaped these distant, often enigmatic bodies. Miranda's unique blend of surface features suggests that tidal heating, a process driven by gravitational interactions with Uranus, has played a key role in its evolution. This process, which generates heat within a celestial body due to gravitational stresses, is thought to be a common phenomenon among icy moons orbiting gas giants. Understanding how tidal heating has shaped Miranda can help us understand the internal dynamics and evolutionary paths of other icy worlds, such as Jupiter's moon Europa and Saturn's moon Enceladus. Miranda's surface, scarred by ancient impacts and sculpted by tectonic forces, serves as a window into the solar system's tumultuous past. Its heavily cratered terrain stands as a testament to the late heavy bombardment, a period early in the solar system's history when a barrage of asteroids and comets pummeled the inner planets and their moons. By studying the size, distribution, and age of Miranda's craters, scientists can glean insights into the dynamics of this chaotic period. Moreover, Miranda's complex tectonic features, such as its coronae and cliffs, provide clues about the internal structure and evolution of icy worlds. These features suggest that Miranda may have experienced periods of intense geological activity in its past, driven by the interplay of tidal heating, internal differentiation, and possibly even cryovolcanism. Unraveling the geological history of Miranda can shed light on the processes that have shaped the surfaces of other icy bodies, including Pluto and its moon Charon. While Voyager 2's flyby of Miranda provided a wealth of data and revolutionized our understanding of this enigmatic moon, it was ultimately a fleeting encounter. Many questions about Miranda's composition, internal structure, and geological history remain unanswered. Future missions to Uranus, equipped with more advanced instruments and capable of longer-duration observations, are crucial to unraveling these mysteries. A dedicated orbiter mission to Uranus could provide high-resolution images and topographic maps of Miranda's surface, revealing details of its geological features and allowing scientists to study their evolution in greater detail. Spectroscopic observations could determine the composition of Miranda's surface ice, providing clues about its formation and the presence of potential organic molecules. Geophysical measurements could probe Miranda's internal structure, revealing the size and composition of its core and shedding light on the role of tidal heating. Miranda, the enigmatic moon of Uranus, stands as a beacon in the darkness of the outer solar system, beckoning us to explore the unknown and unravel the secrets of our cosmic neighborhood. Its chaotic surface, a testament to the power of geological forces, holds clues to the formation and evolution of icy worlds, a class of celestial bodies that dominate the outer solar system. As we venture further into the cosmos, Miranda serves as a reminder that even the smallest, most distant worlds can hold profound insights into the workings of our universe. Its unique beauty, its enigmatic features, and its potential for scientific discovery make it a compelling target for future exploration, a journey that promises to expand our understanding of the solar system and our place within it.